Hello and welcome to Math, where today we're going to learn some one-step equations. All right, first, before we go on, let's do this. Identify some opposite numbers. So what's the opposite number of 8? Well, that would be negative 8. 8 and negative 8 are opposite of each other. Think of the number line, zeros in the middle, right? 8 and negative 8 are the same distance away they are from 0. So they're 8 opposites. So negative 3, what would that be? What would the opposite of that be? Well, that would be 3. Okay? What's the opposite of negative 6? Well, that would be 6. All right, why is that important? Well, that's important because you need to know these things called zero pairs. And a zero pair is a pair of numbers when added together equals 0. In other words, they cancel each other out. So if I added negative 8 and 8, that would give me 0. Negative 8 plus 8 is 0. Negative 3 plus 3 is 0. Negative 6 plus 6 is 0, right? Those are called zero pairs. All right, so identify the zero pairs. Go ahead and pause the video, try that one on your own. All right, hopefully you paused it and tried it on your own. So what might zero pair be with negative 5? Well, that would be 5. What's my zero pair with negative 3? Well, that would be 3. And what's my zero pair with 4? Well, that would be negative 4. And they're zero pairs because if I add these together, it gives me 0. Negative 3 plus 3 gives me 0. Negative 5 plus 5 gives me 0. Okay, that's important to know when you're solving equations, because when you solve equations, you're basically trying to get the variable by itself, alone, all lonesome. Okay, so when solving an equation, our whole goal is we want to get that variable by itself. We want to get it all alone, okay? And we do that by using inverse operations to solve it. All right, so let's think about this. Identify the inverse operations. So the inverse operation to addition would be subtraction. This inverse operation for subtraction would be addition. And we do the inverse operation so we can create a zero pair, just how we talked about. Negative 5 and 5 are zero pairs, right? Well, negative 5 is like subtraction. Positive 5 is like addition, right? So a positive 5 and a negative 5, put them together, zero pair. All right, so how do we solve it? First, we're going to circle the variable because we're going to figure out what we want to get alone. And then we're going to identify the operation that's happening to it. And then we're going to choose the inverse operation to solve. All right, so let's do one together. All right, so I see here I have x minus 3. Well, I'm going to circle my variable. My variable here is x. All right, so what's happening to the x? Well, what's happening to the x is a minus 3, right? It's a minus 3. So what would be the inverse of that? Well, the inverse of that would be a plus 3, because the opposite or inverse of subtraction is addition. So to solve this, I usually draw a wall on my equal sign, and I'm going to do a plus 3 to both sides. Because it's equal, whatever you do to one side, you have to do to the other side. And I do plus 3 because negative 3 and plus 3 are zero pairs. They cancel out. Negative 3 plus 3 gives me 0. It goes away. And then I can leave x on that side. The x is staying by itself, which I want. I want my variable by itself. That's what we wrote up here. So now on this side, I just do negative 6 plus 3. So what's negative 6 plus 3? Well, that's negative 3. That's negative 3. So my answer is x equals negative 3. So the good thing with equations is I can always check my work, right? And I can check my work by plugging in my answer into my original equation. So I see my original equation is this x minus 3 here, right? So if I said x equals negative 3. So to check it, I can plug in negative 3 for x, and I want x minus 3, and that gives me negative 6, which is what they want it to equal. So I know that I got this right. Okay, let's do another one. Let's do this one below it. So I see I have negative 6 plus x. Okay, so I see that I have a negative 6 here, right? So that what would it be a zero pair with negative 6? Well, a zero pair with negative 6 would be a positive 6. And a positive 6, I could put a plus 6. And that's going to cancel these out. And I'm going to do the same thing to this side over here. And 9 plus 6 would get me 15. 15. And on this side, these negative 6 and 6 canceled out, so I'm just left with x equals 15, and that's my answer. So once again, I could check it by plugging into the original equation. So I have negative 6, and then it says plus, and then it says x, and we said x was 15, so I'm going to substitute it in with parentheses, and that gave me 9. And that is what they wanted it to equal, so I checked my work. I know I got it right. Okay, so now let's look at these ones on the right. I have 1 equals x plus 5. Well, I want to get x by itself, right? So what's happening to it? Well, what's happening to it is a plus 5, right? So how could I get rid of it? Well, what's the opposite of a plus 5? It would be a minus, not minus 3, minus 5, okay? So we always do the inverse of what's happening. So this is x plus 5. I want to do a minus 5 because that makes a 0 pair. 5 minus 5 will get me 0. And that leaves me with x on this side. And I want to do the same thing to my other side. 1 minus 5 will get me negative 4. So negative 4 is my answer. X equals negative 4, or negative 4 equals x. It means the same thing. Let's check our work real quick. So let's plug that in. It says x plus 5. So x we said was negative 4. And let me delete all this other stuff on here. There it goes. X, negative 4, and then it says plus 5, and that equals 1. And that's what they wanted it to equal. So we know we got it right. We checked and got it right. All right, so this one. I have 2 plus x. So what's happening here? Well, there is a positive 2. So if I wanted a 0 pair, I have to find the opposite of that, right? So what's the opposite of a positive 2? Well, that would be a minus 2 or a negative 2. And we do that because these cancel out and give us 0 and leave us with this x all alone. That's what we wanted. We wanted to get this x all by itself. So now I can do the same thing to the other side. I'm going to do minus 2 over here. 6 minus 2 will equal, 8 minus 2 will equal 6. So once again, I could always check my work. I can put it in here. It says 2 plus x, so I'm going to do 2 plus, and then for x, I'm going to put parentheses 6, and that gives me 8, and that's what they wanted, so I know I got it right. Okay, so you're always looking to do the opposite of what's happening to the x. You're doing the inverse operation. Okay, so when adding and subtracting, we want to create 0 pairs to get the variable by itself. We want to get the variable all by itself, right? But when we're multiplying and dividing, we want to make the coefficient become a 1, because 1x is the same thing as x. It equals x. When you see this in math, and we ever see an x, there's really a 1 in front of that, and we talked a lot about that when we were combining like terms. Okay, so identify the inverse operations. Well, the inverse to multiplication is division, and the inverse to division is multiplication. Okay, so how do I solve this? Well, 3x, we learned this when we did distributive property and combining like terms. This really means 3 times x, right? So if I wanted to get x by itself, I would divide by 3, because 3 divided by 3 makes a 1. And that's what I want. I want 1x left here. And I'm going to do the same thing to this side. I'm going to do 9 divided by 3, and I have to do the same thing to both sides to keep it equal. 9 divided by 3 would give me 3. And guess what? You can always check your work, right? That's the good thing about equations. You can always check your work. So it said 3x. So I'm going to put 3 and put a parentheses for my x. And we said x equals 3. 3 times 3 gives me 9. That's exactly what they wanted, so I know I got it right. All right, so let's do this one below it. 12 equals 6x. 12 equals 6x. This means 6 times x, right? So I'm going to divide by 6, because 6 divided by 6 gives me 1, and that's going to leave me with 1x. And I'm going to do the same thing to the other side to make it equal. 12 divided by 6 will get me 2. So I'm at 2 equals x, or x equals 2. Same thing. All right, so once again, I can check my work. 6, and then it says 6x. I'm going to put parentheses, and my x was 2. 6 times 2 is 12. Boom, got it right. Checked. All right, now this one, a fraction bar always means divide, okay? Always means divide in math. So this is saying x divided by 2. All right, so what's the opposite of divided by 2? Well, we just said it's multiplication. So we're going to times both sides by 2. And I times this by 2, so I can be left with 1x. And I got to do the same thing to the other side to keep my equation equal. And 4 times 2 is 8. So I have x equals 8. And once again, we can always check our work. So it says x over 2. So I'm going to put my fraction, and on top it says x. Well, we just said x equals 8. And on the bottom I have 2. And what does that give me? 4. That's exactly what they wanted. So we know we got it right. All right, one last one. I have 6 equals x divided by negative 3. Right? So what's the opposite of division? It's multiplication. So I'm going to times by negative 3 to get rid of these and leave me with 1x. All right? And I have to do the same thing to the other side to keep it equal. And negative 3 times 6 is negative 18. So I have negative 18 equals x. All right, so let's check our work one last time here. I have x divided by negative 3, so I'm going to put my fraction bar. X we said was negative 18, and on the bottom was negative 3. That gives me 6, which is exactly what they wanted, so I know I got it right. Okay, so it's always important. You can always go back and check your work to double see if you got it right. If you ever solve an equation and you're like, I'm not sure if this is right or not, you never have to ask a teacher. Just plug it in, and we know how to do that because we learned how to evaluate expressions. We learned how to substitute, right? And you can do it in Desmos, make it nice and easy. But it's a good way to check to see if you got it right. Okay, this is the same thing as it was earlier. All right, let's see. Go ahead and pause the video. Try these 4 on your own. When you're done, get it checked by a teacher. So pause the video, do these 4 on your own, get it checked by a teacher when you're done. All right, hopefully you paused the video and did these 4, and hopefully you got them all right. All right, so now we have one last thing to learn. And that is if the coefficient is a fraction. So a coefficient, remember, that's the number in front of the variable. If the number in front of the variable, like this one is 2/5, if that is a fraction, the way we get rid of it is we multiply it by the reciprocal. And the reciprocal is just a fancy way of saying you flip the fraction. All right, so if it's 2/3, the reciprocal of that would be 3/2. And the reason why that we do that for when there's a fraction as a coefficient is because if I multiply 2/3 times 3/2, that should give me 1. So let's go ahead and put that in our calculator and see. So you can see what I mean. So if I have 2/3 and I'm multiplying it by 3/2, that gives me 1. And that's what we want when we solve equations. We want to get one variable all by itself. So that's how we can do that, because 1 times x would just still be x, right? So we can multiply by the reciprocal to get x alone all by itself, and that will solve our equation. Okay? So what's the reciprocal of -6/5? Well, -6/5, if I dim the reciprocal, I flip the fraction. So the denominator goes to the numerator, the bottom goes to the top, and the numerator goes to the denominator. The top goes to the bottom. So that would be 5/6. All right, so let's try this one on our own. Let's see. 2/5 x. All right, so that means I see a fraction with my variables. That means I'm going to multiply by the reciprocal. Well, the reciprocal means I flip my fraction. So this will be 5/2. And I do that because when I multiply these, 5 times 2 gives me 10. 2 times 5 gives me 10. 10/10 equals 1. Right? So these cancel out and leave me with 1x. And I'm going to do the same thing to the other side because I have to keep it equal because there's an equal sign there. So I'm going to times this side by 5/2. All right, when you multiply fractions, you can just do 10 times the top number. So 10 times 5 would be 50. 50, and remember fraction bar means divide. 50 divided by 2 will give me 25. If you don't remember how to multiply fractions, it's okay because you're allowed to use Desmos, right? Or a calculator. All right, so I would do 10 times 5/2, and I get 25, right? And remember, you can always check your work. So if it's 2/5 x, I can write 2/5, put parentheses, and put 25, and it says it equals 10. Well, that's what I want it to equal, so I know I got it right. Okay? All right, last one. I have 4/3 x. So I need to times this by the reciprocal. So I'm going to times it by 3/4. Because 3/4 times 4/3 cancels out and gives you 1x, and that's what we want. And I'm going to times that to the other side. So I'm going to do 12 times 3/4. All right, so then that's going to leave me with my answer. X equals what? I don't know. 12 times 3/4. Let's put that in the calculator. 12 times, I hit the wrong button. 12 times 3/4 gives me 9. So X equals 9. And remember, if you want to, you can always check your work, right? You can check your work. So I see it says 4/3 x. Well, I'm going to put a parentheses for x, and I'm plugging 9, and that gives me 12, and that's what they wanted. They wanted 12, so I know I got it right. Okay, so that's how you solve a one-step equation. You're always looking for the inverse operation. Basically, what you're trying to do is you're trying to figure out what is happening to our variable, and you want to do the opposite of that so you can figure out what your variable equals. If you ever have any questions, please see a teacher. I'll check you next time. Bye-bye.